All right, hello. Today we're starting logarithmic functions, logs. Um, I was thinking we were going to wait with these till after spring break, but we've got the end of this week and we've got next week. We're going to have a quiz at the end of next week, and part of that quiz is going to have to do with logarithms. We're going to save the natural number and compound interest and all of that stuff, solving exponentials and solving logarithms until after spring break. We want to introduce what logarithms are today, what they look like on a graph, and maybe rearranging them, how they're related to exponents. Okay, so how do we spell it? Log is the shorthand. On a calculator, you're going to have a button that says log. You're also going to have a button that says ln. Log is the shorthand for logarithm. Okay. So we'll talk about the ln part after spring break, but log is the shorthand for logarithm. And a logarithm is an exponent. Now, this definition in this way is going to be really helpful. I would memorize this. Logarithm is an exponent. Okay. Um, so it has a base. Has a base. And it has an exponent, or it is an exponent. And by is, I mean the math idea of is, that is the equal sign. So how do we write these? What are they going to look like on our paper and our calculator? Log with a base b y and an x. So here, the pieces, let me make sure these colors make sense. This is the base. This is the exponent. And this is the value. I'm not sure. I don't think there's like a specific name for this piece, but it's the value of the exponent. So a logarithm is the inverse of an exponent, really. But what I mean by a logarithm is an exponent is the log part, log, L-O-G. This is shorthand. We would have like parentheses here. This is going to be a number. This is going to be a number. This might be a number. These three are going to be numbers. Log is just short for logarithm. It's kind of like the trig function, sine, cosine, and tangent, which we're going to get to much later, but maybe you've heard of those before. The LO and the G are not variables. They're the name of the function. Okay. And the exponent is what the log, this stuff, is equal to. And we're going to use a calculator a lot to evaluate these. Okay. So this is a logarithm. And what we can do with a logarithm is this is only true if and only if. This just means you can start from this information and go to the next information that we're going to talk about, or you can start here and go to this. So it's circular. This is only true if b to the x is equal to y. So we should be able to, by the end of next week, be able to go from a logarithm to this exponential statement, or from this exponential statement back to the logarithm. We want to be able to rearrange them. So you'll notice some stuff. This exponent is the exponent of this equation. This base is the base of this exponent. And then the y here is the value of whatever the exponent is after we simplify and calculate it. So this base is still the base. This is the exponent. And this is the value. Now, why would this be useful? Why would we use any of that? Well, if you know the value and the base, but you want to find the exponent, you need the logarithm, because the logarithm is equal to the exponent. So if you know these two numbers, then you can calculate this. Graphically, I also want to show you what a logarithm looks like. So we're going to go to Desmos. And I have a logarithm already put into Desmos, but we'll talk about how to type this in. We're going to be doing a lot of calculations with logarithms, so it's going to be useful for you to know how to type it into Desmos. But here's a logarithmic curve. It should look pretty familiar. It looks kind of like the exponential curve. That's because they're intimately related. This is the inverse function. And so here is the corresponding exponential curve. And they both curve through kind of the same coordinate points. We've just swapped the x and the y's. Right, so they both go through, or this one goes through 0, 1, and this one goes through 1, 0, the log function. So this crosses the x-axis, but it never crosses the y-axis. There's no value over here for the blue function. It does not cross this thing. And we could have, this is like a growth logarithm that goes with the growth exponential function. We could also have, right, if we put a negative here, then it flips it. And if we put a negative here, no, here, no, yes, actually. Now those are inverses, I think. Yep. So there is a logarithm for a decay. You'll notice it doesn't cross 0. Doesn't cross 0 on the y-axis. So it doesn't go over here. Or it doesn't cross 0 on the x-axis, I'm sorry. So those graphs are just flipped over the line y equals x. So this purple curve here, or this purple line here, it's reflected over that curve, and then they would match up perfectly. The other one's a bit confusing where I put the negatives in. Those do flip over that purple line to meet up perfectly, but because they're kind of on top of each other, it's a bit harder to see. But if we were to like fold the screen in half, right on this purple line, the blue curve and the green curve would match up. They're inverses of each other. Okay, so a logarithmic curve has the same kind of curve as the exponential. All right. So let's practice going between these two forms, mostly going from the log to the exponent, because we want to be able to evaluate this. If we know these two numbers, we want to be able to evaluate it. Oh, and how did I type in the? Maybe we'll come back to that. Okay, so we're going to rewrite the logarithm as an exponential function. So all the values are here already. We're just going to rewrite it as in exponential form. So it will contain all the numbers again at the end. So there's no solving here. We're not trying to find a variable. We have all the numbers already. 0 log base 12 of 12 is 1. Burn out of room. Log base a quarter of 4 is negative 1. So all of these are saying, let's interpret the log. All of these are saying if I have a base of 2, what exponent do I need to get the value here? In other words, well, exponential form is 2 to the 4th equals 16. So I took the base of the logarithm, and I made it the base of the exponent. I took the exponent. The logarithm is equal to the exponent. The logarithm is the exponent. That's going to be probably the most helpful phrase for these. Is the exponent. I made the exponent, and then the value inside the logarithm, that's what the exponent is equal to. And we could calculate 2 to the 4th. 2 times 2 is 4. 4 times 4 is 16. So this is true. Okay. I don't know why I'm writing this again. Sorry. Here the base is 4. 4 to the power of 0, the logarithm is equal to the exponent, is 1. Our value is our value. 4 to the 0 power is 1. 4 to the 0 is 1. Here we have 12. The base is 12. So the base of my exponent is 12. My exponent is 1. 12 to the first is 12. Okay, this one's looks tricky maybe because there's a fraction involved and a negative. What we're saying here is the base is a quarter. The exponent of that fraction is negative 1, and that is equal to 4. A quarter to negative 1, we flip this over. Negative exponent means we make a fraction out of it, and it becomes 4. Calculators are really good at calculating this without knowing the exponent. Your calculator will do log base 2 of 16 and give you 4. Okay, so it's like if we know these two numbers, and we'll talk about solving much later on, but if we know these two numbers, we don't know that number, we want to find it. What value do I need? What exponent value do I need to raise 2 to get 16? Well, I would use a logarithm to rearrange this to find that value. Okay, we're using something that I like to call the toilet bowl method. And this is what my teacher in high school called it. It hasn't really changed since then. And it really has very little to do with a toilet. Also, swirl is what I've heard it called. This is mostly just a phrase to get you to remember the thing. I have a logarithm, and normally we use like a lowercase l. It's fine. With a base, we have some value, and we have the exponent. To rearrange this, use swirl counterclockwise from the base. So you start here, you go this way, and then you get that. So b to the power of x is equal to y. So we're using this swirl. We're starting from the base of the logarithm. Base of the logarithm matches with the base of the exponent. We raise to the power of x, b to the x power equals whatever's inside the logarithm equals y. Okay. You also need to be able to go the other way. You need to be able to go from this back to the log form. B to the y gives us x. Log with base b with y inside, looks kind of like it's raised to the exponent, is equal to x. The exponent is what the log is equal to. The base of the exponent is the base of the log, and the value that this exponent is equal to is the value inside the logarithm. Okay, and we'd call it the toilet bowl method because we're going around, counterclockwise, swirling around the equal sign. Okay, so let's now practice going from this, we have an exponent, back to a logarithm. So we're going to do the same thing. If I could spell. Rewriting exponents. 5 squared is 25. These are all things we already know, or should be able to calculate using a calculator, or figure out. Some of them are going to look kind of weird, like this one. 8 to the 2/3 is 4. Okay, but the numbers are not what we're worried about right now. We're just going to assume that these are all true statements. We could plug them into a calculator and check, but we're just going to assume that they're all true, and our goal is to just rewrite them in logarithmic form. So our answer is going to have a log in it. So we're rewriting the exponents as logs. So here, the base is 5, the exponent is 2, and the value is 25. So log with base 5 of 25 is 5. Okay, you don't need to write this out every time. We're also basically doing kind of the swirl method. We're saying, okay, if my base is 5, then the value inside is going to be 25. That equals the exponent of 2. So here the base is 10. So log base 10 of 0.1 is equal to the exponent, which is -1. Yeah. Okay, here the base is 8. So it's log base 8 of 4 equals the exponent, which is 2/3. Log base 6 of, so it equals 2/3, of 1 over 216 is -3. How do we know that's right? Well, we should be able to work backwards to this exponential statement. We should be able to go from the logarithm to the exponent. So if I raise 5, well, that's certainly not right. I wrote it wrong. That should be a 2 because it was 2, exponent of 2. So 5 squared is 25. We should be able to go back and work our way back around to get our exponential statement. The other way is to just plug it into our calculator type this logarithm into a calculator and see if it's actually the right value. So I don't want to make any promises. I have scientific calculators at school, so if you have one of those are great. Your phone can also do a logarithm, so if you like turn it on its side or make it show all the buttons, all the math options, logarithm should be there. The other way, just go on Desmos and type in log, or use the keyboard here. Functions, there should be logarithm under miscellaneous. And there's two different ones. This log base A is going to be really helpful because then it makes it easy to type the base in. If you just type log, you do say, let's do like log of 2, or let's do like a big number, log of 100. We get 2, which should make sense. This is like a really small function here. But when you're doing this, there's no base written here. It's assumed that it's 10. So we'll write that in our notes in a second. But you need the base, right, to calculate whatever this is, whatever we're trying to calculate. So if we're trying to do log base 5 of 25, we can use the functions miscellaneous and then use log base A here. Or if you're just typing and you want a base, type in log, L-O-G. You do shift and then the hyphen, and it'll do a subscript or the minus sign right next to the plus and equal sign on your keyboard. And so we can put 5 in the base and 25 inside the log, and then we get equals 2. So Desmos will also do all your logarithm calculations. So again, that was type in LOG, and then shift and the minus sign to go to the subscript. And then we can type in the base of 5, 25, and it equals 2. Or if you want to use the button, you just put the base in right here, put in 25. Okay. Now what's happening when I do log of 100 is this is the same as log base 10. So base 10 is so common because we live in a base 10 world. We count to 10. We use our number system as base 10, kind of, mostly. We don't need to get to the philosophy of that, but base 10 is so common that we just shorthand log with no base as base 10, which is the next one that we did, right? We said log base 10 of 0.1 equals -1. This is the same as log of 0.1 equals -1. No base. I mean, the base is there. It's 10. So log without a base assumes the base is 10. Okay, so for this, we just need to type in our calculator log 0.1, and we should get -1. So log 0.1, and we do get -1. What this is saying is we have a value here, the base 10. What exponent do I need to turn that 10 into 0.1? Well, 10 to the -1 gives us 1 over 10, which is 0.1. Okay, so we should be able to type all of these in. We also had log base 8 of 4. So log base 8 of 4. And we get this fraction, or this repeating decimal, which is the same as 2/3. And then the next one was log base 6 of 1 divided by, we're going to need parentheses, 1 over 216. Let's see there, and we get -3. What this is saying is 6 to the -3rd gives us 1 over 216. Okay, so we're going to be using a calculator a lot to calculate these logarithms. We will need to be able to rearrange them by hand, like we did here. We took the exponents and turned them into logs, and we also talked about how to turn logs into exponents. We're going to be able to do that by hand. It's going to make things way faster, and it's going to help us solve later. But we're also going to be using a calculator to calculate values of logarithms. Okay. And if you just see log, like log of 20, this is the same as log base 10 of 20, which I don't know what that is. That's probably a weird number. 10 to what number gives us 20? It's going to be a decimal, or like 1 point something. Because it's bigger than 1, 10 to the first would be 10. To get to 20, it's not squared because that'd give us 100. So it doesn't equal 2. It's between 1 and 2. So we're going to get lots of big decimals for our logarithms. Okay. So that's it for logarithms today. You'll have a thing to work on, and that's it. That's our introduction to logarithms. And rewriting exponents as logarithms and rewriting logarithms as exponents. Exponents and logarithms are the same thing. I know logarithms are going to be kind of hard to wrap our brains around. It's going to take some time. That's okay. It's brand new. This is one of the, not few, but it's one of the things that we're doing in Algebra 2 that I don't expect that you have ever seen before. This is your first sight of it. Okay. What we have basically said is that this is the inverse function. We have swapped the x and the y of a function. We swapped their positions in the equation, and this is the new function that comes out. Logarithms come out. Okay. So that's it for our intro to logarithms.